right, welcome back everyone. Today we're going to do a short video on how to use the XTAPER function within the Prolink control. What we're going to focus on today is how to create a profile and make it an XTAPER part. We're going to learn how to take an existing profile and turn it into an XTAPER part. And then we're going to learn about taking existing XTAPER parts that have been pre-done and saved and take the XTAPER function away. So let's get started. The first thing you need to do when you're creating an XTAPER part is you got to have your part. So it's no different than creating any other part. Select your material. Let's see what we got here. Okay. Select your material. Right. And write your program. I'm just going to use a simple U channel in this illustration because it's going to be a little bit easier for everyone to follow. Okay. And I'll turn this into 3D. So what's the function of making an XTAPER part? An XTAPER part is nothing more than assigning one side of this part to be smaller than the other side so that when you string several of these together, one end of this part can slide into the other part. Okay? It's as simple as that. Now, in the past with other machines and other controls that I've worked with, when you're doing tapered parts, you have to do the math, you have to figure everything out. But they've made it so simple on this control that anyone can do this, and it should be very easy to teach how to do this, all right? So we're gonna get started. Let me turn this back into 2D. Now, we have our 2D part. We've written what we want, right? And now we're gonna finish the profile, and we have our piece. We can come here and arrange our bend order. Let's say I don't want to bend it like that. I want to turn this around and I need to use different tools, whatever you want to do with this part. Okay. Just get your part like you want it. Change your sequence, do all the things that you need to do. And then you can come back, or you could have done this before you changed all this stuff around. Okay. Doesn't really matter. See this icon down here in the bottom of the screen? That is the part, that is the icon that takes this part and turns it into a taper part for you. So here, let's click it. And it says, do you want to open this segmentation calculator? Yes. Now, within this segmentation calculator comes several things. Now, all you have to do is define the things that you want, right? It's going to start out by looking at your material table. Say, hey, I have 48-inch blanks. If you see your material table here, all right? But nobody really works with 48-inch blanks. So let's go back. I'm going to take this profile and I'm going to choose one that has 120 inches because that's the most common item. All right. So now we're working with a material table that uses 10-foot pieces. Okay. And open the segmentation calculator again. And now it's doing its calculation based on 10-foot parts. See what's going on. All right. So within this pop-up window here is everything you need to define it, manage where the scrap is going to be, establish your procedure for running it, and calculating how many of these pieces that you're going to need for your job. So let's get started with that. The very first thing you got to do is tell it, how long is my job? I'm doing a roof. That roof is 4,000 inches long, and you have to define this in inches, okay? So we're going to come here. We're going to say, hey, I have a job, and I need 4,000 inches of coverage, okay? There. The next thing we want to do is say, how much overlap do I want? What this means is how far do I want one piece to fit down inside of the other? It needs to know this so that it can make the male and the female side of it wider or more narrow so that it can have a larger overlap. Okay. 6 inches, 4 inches are pretty normal. All right. Just because you assign it 6 inches doesn't mean you have to overlap that part by 6 inches. You can leave it at 2.5 if you want. It's just there so that the machine can calculate the width so that you can slide the part as far as 6 inches if you want to. All right. And again, it's looking here at what size is my blank and it gets that from the material table. Okay, so you're going to need to make sure that your material table matches the length of your blank. Okay, and then in the middle here it says, do I want to make this thing feed overlap from left to right, or if I click this one, I'll make the opening so that it overlaps from left to right, or sorry, right to left. Meaning the one on the left will sleeve into the one on the right. And if I choose this one, the one on the left will overlap the one on the right. Okay, the machine will do it for you. All you got to do is tell it which way you want, because if you have a roof that's pitching down from right to left, this is the option you want to choose. If you have a line that's pitching and going from high ground on the left to low ground on the right, this is the way you want, because you want that water to flow or according to your overlap or your underlap. Okay, then you got to manage the scrap. When you're making a tapered part, you're going to be starting with rectangles where you have parallel sides. Okay, you're not going to be cutting a tapered blank. Okay, so when you do that and you start making these tapers, that part is going to skew itself and it's going to have excess. One end of it is going to be larger than the other, and we have to bury that excess somewhere. So you have three choices. You can tell the machine to equal it out, make the first bend and the last bend both equally absorb any disparity from making this part. You can choose this one in the middle. This one will put all of the disparity on the very first bend of the part. If you have a hem and you have a bend that's coming right after the hem, you probably don't want to do this, because the hem is going to be really large on one side and it may infiltrate the bend line of the next bend that you want to make. All right. Or you can put all that excess material on the last part. Usually parts that have a nailing strip, for example, a drip edge or whatever, if your bend sequence is that you're bending that nailing strip last, then this is the option you want to use, because we don't care if that nailing strip absorbs all this disparity. It's going to get screws put in it and covered up anyway. So these are the three choices that you have for choosing or for selecting where the disparity in the material goes. Now, the next choice here, this is how I define how the machine is going to help me run this part. Okay, with the arrows. You can either run this part by shifting it left and right, or you can run this part by holding that part in the middle. So let's explain a little bit about why we need these things. All right, in order to make tapered parts, the machine needs a known reference to calculate these triangles. Okay, anytime it does tapered parts, and we're going to get a little bit more into that here in just a minute. All right, it has to do the math and figure out what the triangle is. So if you look at where all this excess is, right, it skews the part, and what you have essentially is a triangle. But it needs a known reference point in order to start calculating for that triangle. Okay, so the easiest way for you to do it is to select this option. And what's going to happen when you run the program is a little arrow pointing left or a little arrow pointing right is going to pop up on your screen as you go to each bend line. Okay, and what that's telling you to do is you need to take the part and move it all the way to the left or move it all the way to the right hand side of the machine. And you're going to hit the squaring arms. And for those of you who've installed a machine with an XTAPER back gauge, there's two squaring arms that come with the machine. One goes on the left, one goes on the right. These are actually your side stops that apply to these arrows when you run the part. The next option is to keep the part in the middle of the machine, and the machine will calculate around that. It's assuming that you're centering up that part in the machine. And you don't have to be exactly accurate if you're holding it in the middle of the machine. The more accurate you are, the better you're going to be with your taper. But you don't have to be exact. If you're an 1/8 inch or a 1/4 inch from center, not a big deal. But if you get lazy and you're an inch and a half off, well, you do the first bend and you're 1.5 inches off center to the left side, and then you do the next bend and you're 1.5 inches off center to the right side, you got a 3-inch offset. That can really affect your triangle and how it calculates or how it actually performs with the width here from left to right. Okay, so you really need to try to keep that part in the center. All right, so that's how we calculate that. But you notice I told it I have 4,000 inches for this job, and I run 120-inch pieces. So what it did for me was it calculated that I need to cut my pieces 116.994 inches wide. That means from left to right. And I need 36 of them. That's how many it takes to do exactly that job. But everyone knows in roofing, nothing is exact, right? So if you look into the left-hand column, the item we have selected here, the method that we have selected is for the machine to calculate for you exactly how many you need and how long they need to be. But no roofer is going to take his 20-inch blanks and trim them down and send them out to a job. Okay, he's just going to cut 10-foot sticks for the most part, and he's going to say, yep, I need X number of these at 10 foot. They can take the snips and cut these things when they're out in the field. And that's typically what happens, right? So if you choose the second option, watch what happens. It says, hey, all right, I'm just going to calculate this based on 120-inch blanks, and I'm going to give you how many it takes if you're going to do them all in 120-inch lengths. If you look here, it's the same number, 36 of them. It's just going to have some excess when you get to the last one. The guy's going to have to trim it off. Okay, that's what the second option does. Now, you may find some of the guys, roofers out there, that they say, hey, all right, instead of cutting all of them at 116, I want to do as many 120s as I can, and then I'm going to make one piece, and the last piece, I'm going to make it to exactly what I need. So if you select the option on the bottom, you notice I have a check mark here. We're not ready for that just yet. So when I select this option on the bottom, it says, all right, you need 35 10-footers. Remember before it was 36? You need 35 10-footers to do this job. And when I select this box, it's going to say I need one at 10 inches, right, in order to do that job. Well, for this thing to taper and give you enough on a 10-inch blank, that back gauge has to really skew itself, right? It really has to be a severe disparity. And the limit for the machine is going to be 5 millimeters of disparity per meter of the machine. So you got roughly 15 to 17 millimeters of disparity over your 10-foot machine, which is about 5/8 of an inch-ish. Okay, somewhere along that range. Okay, so a 10-inch part is not going to work with that much disparity. So in this case, you wouldn't be able to use that. I talked to Roger and Elmer at the factory, and the machine really works best when you have a part that's probably 5 feet, 6 feet, and longer. Okay, so if you're calculating what we call a splice piece, and it's under 4, 5 feet, maybe 6 feet, then you need to rethink it and go back and just use this method and let them trim that piece. Okay, it's not that it can't do it when it's a 4-foot piece or even a 3-foot piece. Depends on the part and how much disparity you're using. You're welcome to try it, but a 10-inch piece, it is not going to do. Okay, it won't be able to skew itself enough to make that. All right, so just to recap what these icons are, this is what tells me the total length of the job. This tells me how much of an overlap or an underlap that I want. This tells me here if I'm going to go underlap to the inside from the right, or sorry, from the left. And this icon tells me if I'm going to overlap from the left. This tells me that I'm going to divide all the disparative material equally from the first bin to the last bin. This one tells me that I'm going to put all the disparity in the first bin. This one tells me I'm going to put all the disparity in the last bin. I typically run my parts like this in the very, very beginning and see how they turn out. This icon tells me that I'm going to run that part trying to keep it exactly in the middle of the machine. This tells me I'm going to follow the arrows during the program, and I'm going to be positioning my part all the way to the left or all the way to the right, depending on what the machine tells me to do. All right, so let's see what this looks like. I'm going to go here, and just for the simplicity, and we're going to say done. So now you have completed creating a tapered part. When you go to the profile and you click on the back gauge, you'll see this is 10 inches on one side. It says 10.025 on the other. Now, had I selected it to be an overlap in the other direction, these two numbers would be reversed. It would be 10.025 up here and 10 inches down here. Now, just like any other custom program, I cannot modify these dimensions on the screen. I can only view them, okay? But if I needed to make a back gauge compensation, meaning the whole thing, that flange as a whole, needed it to add a 16th or subtract a 16th, right? Now I can enter here. I can add here 0.062, okay? And when I go forward, it's not going to change the back gauge number here. It's going to do it in the background. It's going to add a 16th to that flange, okay? Which means this is going to be actually 10.062, and this is going to be 10.087 when it really comes to the bend line, okay? Just like a normal profile. It's no different. Now, we talked about calculating the triangle and balancing this material. So let's go back to the graphic. So we have our part here, right? I'm going to put it in. If I put it in 3D, it'll be too much. So let's go here and let's click on our flange. Let's say I don't want that to be a 2-inch bend anymore. Here's where I can change that bend, just like any custom program, all right? But if you notice, the lines here are not parallel anymore. They're skewed, right? This you can look right here on this icon and tell if this program has been done as an XTAPER. You can also look down here. There'll be a check mark on the segmentation calculator. So let's highlight that flange. Okay. So what do we got here? This is telling me that one end of that flange is going to be 2 inches, and one end of that flange is going to be 25 thousandths less, right? To support the taper. The part is 120 inches long or wide, however you want to define it. The angle in this angle in this triangle is negative 0.01 degrees. If these were going in the opposite direction here, 2 versus the 1.975, that would be a positive 0.01 degrees. And the disparity between the two is 0.25. All right. Now I need to modify this. Today, I want to run this at a 3-inch flange, right? But you can't just come over here and click it because it's going to bring you the screen. I can't just come here and say, give me a 3-inch flange. If I do that and I say, okay, it's going to give me an error. It's going to tell me that I changed one side of that part, but I have a delta, right? A disparity of 1 inch. What I forgot to do was add the inch to the other side. So if you add 1 inch to this side of the part, you have to add 1 inch to this side of the part. So it's going to be 2.975. So a lot of you guys have probably seen this error out here when you're trying to change stuff, right? And didn't know why. So now I'm good to go. Still only have a disparity of 0.025, right? And that's a little bit lenient if you're within 4 thousandths, 0.1 millimeter plus or minus of that number, you're not going to get a triggered alarm on that delta. Okay. If you stay 4 thousandths and under, then you're fine if you don't type in exactly the same number. But once you get outside of 4 thousandths, it's going to give you an alarm because the tolerance is 0.1 millimeter between left and right from what the machine has calculated. All right. So just to review real quickly, if you need to change the length of a flange on a part, you can modify these parts. Okay. Click here just like you always do. And you tell it the new size, but however much you add or subtract from this side of the part, you must also add or subtract that amount from this side of the part. Okay, that's the way you can do this. All right, this is calculated that angle, and this is telling you actually how much bigger or smaller the left or the right side should be from each other. And this is simply how long is the blank. You also have here your option of changing how you run the part. You can tell it you want it to shift left or right, or you can tell it you want to stay in the middle. So let's just view what this does for us. We'll go to the file and we'll hit play. Now you see here, this arrow pops up. So when I make that first bend, I have to put this part all the way to the left side of the machine. Let's go back. Let's go to line 2. I run line 2. It's telling me that I need to turn the part around and I need to put it all the way against the right-hand side of the machine. Okay, it's walking me through making this part. Now let's go back. Okay. Let me choose center. Okay, and let's see what that does for you. You go to run the part. On every line, it's going to tell you that you need to keep the part in the center of the machine. Okay. Existing programs that are already turned into an XTAPER part. All right. So let's say we pull up this part. When you save this part, we're going to call it Z. So now I go and I'm going to search for, search for 1C. Right? There's nothing here that indicates this is a tapered part. Right? You have to open it up. You can open it up. As soon as it displays the graphic, you can look right here. You can look right here and you can say, you'll know right away that this part is set up to be a tapered part. Now, how do I take it away? Right? Customer doesn't want to run that one as a tapered part. He wants it to run as a straight part, and he doesn't want to have to redo all the work. It's as simple as clicking that button and turn it off. Okay? And then save it as another name. Z. Now you have that same part with and without taper. It's that simple. If you notice, when these two lines here are parallel now, when I click it, I have my normal leg length so I can modify that part. I can change the bend order. I can do anything that I want to do. Okay. So I think this kind of covers how to create a taper, an X-tapered part, what all the functions are, and how you can use it. But now I'm going to show you just one example of a part that people want to do as an X-taper. It's doable, but not every part is really conducive to making X-taper or to making conical parts or tapered parts or whatever everybody wants to call it this week. So let me give you an example. All right, the good old classic S-lock. Okay, I'm just going to program one of these. Him. Go open. We're going to come back this way, and we're just going to put a tail on it. Whatever, it doesn't really matter. The big concern is programming this as an X-taper. Okay, programming it to be an X-taper is easy. Okay, not a big deal. It's the same as before. All right. Oh, I didn't choose my material table. Let me choose the better material table because 120 is the most common thing. All right. Didn't have to rewrite the program. Just go pick a different material table. All right. Cool. So now it has created an X-taper part. How do I know? I can go look here. I can see all the different pieces. All right. I can select this flange. I can see. Oops. How much overlap did I get? Oh, I know why. Let's see where. There we go. Open it back up. Now we're going to give it overlap. Okay, there we go. I had to redo it. Okay. There. Okay. Got 8 inches on one side. Got from here to here, it's 8 inches on one end of the part. And on the other end of that part, from here to here, it's going to be 8.093, so that it can fit around the outside like this and overlap around the outside here. Okay, so now let's go to this flange. Okay. This one is going to be 8 inches on one side, and it's going to be shorter on the other side so that it can nest between here to here and fit inside of that hem. Okay. So it's going to have to come and wrap over and then go inside and go under and then come back to here. Right. That's what that part is going to look like. Right. So you see it's quite a bit of overlap here. All right. But, and getting around the S-lock as far as horizontally is not a problem. Machine can calculate it. You can bend it. It'll work. Okay. It's nothing special to do. But when you make this part and you press that hem, you have to have, first of all, enough opening for these to fit inside. Okay. You have to leave that part open enough. But one side of that part has got to be a little more open than the other side because of the lengths. Okay. So you're going to have this side open, let's just say an 1/8 inch, and then the other side is going to have to be a couple of material thicknesses, either more or less than that, for that to nest in properly. Okay. So just keep that in mind. S-locks are doable. Just got to be mindful of opening that hem the right amount on each side so that everything kind of fits in. Okay. So hopefully this little video will help you in some of your questions with doing X-tapered parts, turning a part from scratch into an X-taper, identifying an X-tapered part, and taking a current X-tapered part and taking it out of that mode, and how to do an S-lock, because I think that's the most common one that people will struggle with. Okay. Thank you guys for watching, and have a good day.